Hello everyone, my name is Manish Kotaki and today I will be presenting on a survey on machine learning and autonomous vehicle perception. Okay, so what are autonomous vehicles and why do we need autonomous automobiles? So automobiles that can drive themselves are referred to as autonomous or self-driving vehicles. They are artificial intelligence. They have artificial intelligence, sensors, and cameras that help them uh, traverse the roadways, make judgments, and interact with other vehicles and infrastructure. Autonomous vehicles have the potential to reduce accidents caused by human error, elevate the traffic congestions, and enhance accessibility for people who are unable to drive, and also increase the transportation uh, safety, accessibility, efficiency, and sustainability. Machine learning algorithms can analyze sensor data from cameras and the lidar scans and help the autonomous vehicles identify objects and decide how to navigate. Autonomous vehicles can become more precise, effective, and responsive to changing road conditions by applying machine learning. So, how does an autonomous vehicle perceive its environment? The autonomous vehicles are fitted with hardware equipment such as cameras, lidars, so radars, GPS, etc. to gather input from its surroundings and send this input to the processor which are equipped with machine learning and deep learning algorithms such as convolutional neural networks and recurring neural networks, also known as CNNs and RNNs, uh, to process these inputs. These algorithms are either used individually eh, or together to process these inputs more efficiently and provide the data to help the autonomous vehicles identify the objects and decide how to navigate. Perception of lanes and on-road obstacles. Perception of lanes is an important task for an autonomous vehicle as it is required for the vehicle to know where it is going and also to avoid the risk of running into other lanes to avoid accidents. There are a few cases where detection of lanes is difficult, where there are heavy shadows, severe mark degradation of the lanes, and also when vehicles are obstructing the cameras from the lanes. So there are a few cases where CNN and RNN needs to be used together to predict these lanes to predict these lanes while moving forward. So there are a few lane detection methods. They are encoder and decoder, CNN plus RNN, and FCN, which is a fully convolutional neural network. So let's talk about deep learning. Deep learning is a subset of machine learning that involves training artificial neural networks with multiple layers to perform tasks such as image and video recognition and also decision making. Um, each layer of the neural network extracts a feature from the input data that are collected from the input devices such as the cameras and the lidar scans and process these inputs using the machine learning algorithms and and the final output layer produces the prediction or a classification of the object that it has captured. Deep learning has become an increasingly popular machine learning technique for for use in autonomous vehicle perception, and due to its advances in computing power and availability of large data sets, and also improve in the neural network architectural design. um, here we are using the kitty dataset that has more than more than 14 million images with which are classified into classified into various subsections and categories. However, deep learning models are often complex and require large amounts of training data, which can make them difficult and expensive to develop and maintain. Deep learning for autonomous vehicle perception. Deep learning has proven to be very useful for the autonomous vehicle perception, as it allows vehicles to interpret and understand the complex and diverse data gathered by their sensors. Here are some specific uses of deep learning for autonomous vehicle perception. First is the object detection and tracking. Deep learning models such as convolutional neural networks can be used to accurately detect and track objects in the environment, such as other vehicles, pedestrians, and obstacles. Um, Next is the semantic segmentation. Semantic segmentation involves dividing an image into different regions and assigning labels to each region based on its contents. This is useful for identifying and distinguishing different types of objects in the environment, such as road markings, signs, traffic lights, etc. Next is the depth estimation. Depth estimation involves determining the distance between the vehicle and objects in the environment. So this is important for tasks such as collision avoidance and lane keeping. Next is the scene understanding. Deep learning models can be trained to understand the context and layout of the environment, such as the location of roads, buildings, and other landmarks. And finally, sensor fusion. Autonomous vehicles typically use multiple sensors to gather information about the environment, such as cameras, LiDAR, and radar. Uh, Deep learning can be used to fuse this information together to create a more complete and accurate picture of the environment. Overall, deep learning has the potential to greatly improve the perception capabilities of autonomous vehicles, allowing them to operate more safely and efficiently in a variety of environments. To conclude, the survey on machine learning for autonomous vehicles perception reveals that object detection, lane detection, and pedestrian detection are typical perception problems, and deep learning and reinforcement learning are the most widely used techniques. The survey results offer knowledge into the benefits and the drawbacks of the various approaches for various tasks, which might direct further study uh, and advancement in this area. Overall, the survey provides insightful data that will help advance autonomous vehicle technology and perception systems. Thank you.